In this video, we're going to evaluate the definite integral of 1 over x multiplied by the square root of x minus 1. And that's going to be evaluated from 2 to 4. And I'm going to use a U-substitution for this one. I'm going to let u equal to this radical right here, the square root of x minus 1. And then I'm going to find a representation for x in terms of u, and of course also for dx. So we have this integral written in terms of u. We'll have to change the limit of integration if we leave it in terms of u. So you have the option to bring it back in terms of x once you integrate and leave these limits. I'm going to change the limits of integration. So just to save some time here, and so you can read my writing a little bit better here. So here's what we have. U substitution, u equals to the square root of x minus 1. So then I squared both sides, gave me u squared is equal to 2x minus 1. Then I took the derivative in this form here. This will be with respect to u, so this will be 2u du. Derivative of x minus 1 is 1, or dx, so we have this right here. And then we're going to need a replacement for x, like I said. So from this part right here, I solve that for x. Take the 1 over, x gives me u squared plus 1. And then I'm going to use it in this formula. It tells me anytime you have an integral written in this format, du over u squared plus a squared. The u is usually going to be a function of x, and this a here will be a constant. Now, if you have a constant multiplying here, that's fine, because you can always bring out a constant. So if you have like a 4 or a 3 here, you can bring it out, and it's still going to give you this answer, and then you just multiply the final answer by whatever that constant is. So in this format, it's 1 over a arctan u over a. Remember, this is the same thing as tangent inverse of the angle. So this is going to equal. Now we're going to go ahead and transform the integral. I'm going to leave the limits of integration out for right now because I am going to change them. And that's putting everything in. dx, then right here, dx is the same thing as 2u du. X is the same thing as u squared plus 1. And of course, the square root of x minus 1, that's your u. Then we simplify and integrate. Well, you've got a u here and a u here. So this leaves me with 2u times, or 2 I should say, because the 2 canceled out. So let me just rewrite this. And so you can see the solution here. I'll take the 2 out, just to make it easier to see the formula we're using. That's the dE there. And that leaves me with u squared plus 1 in the denominator. Now you can rewrite 1 as 1 squared, or visualize it as 1 squared. So that fits this form right here. The integral of du over u squared plus a squared. In this case, of course, u is u, and the 1 can be a, because that's 1 squared. So it's a. So according to this formula, then, this is going to be the integral. Now at this point, I'm going to go ahead and put the limits of integration here. So let's do it this way. When x is equal to 2, okay, the limits go from x equal 2 to x equal 4. We're going to transform that to u. So when x is equal to 2 over here, 2 minus 1 is 1. The square root of 1 is 1. That tells me that u equals to 1. So this lower limit then is 1. Now for the upper limit, when x is equal to 4, that'd be the square root of 4 minus 1, that's 3. So that gives me the square root of 3. U is the square root of 3. So the limits of integration then would be from 1 to the square root of 3. So I still got the 2 right there. So bring down the 2. That's outside. Okay. You can always factor a constant from the integrand. So now for this right here, that's just arctangent. And from the formula, see, that's u over 1. In our case, I'm sorry, that's u over a. So it's going to be 1 over a for this formula. 1 over a, arctangent, u over a. So we have the u, and the a, of course, is 1. So it's u over 1. It's just going to give us u. We got that. And this is now evaluated for 1 to the square root of 3. So this will be then 2 times arctangent of the square root of 3. So let's do it this way. This is 2 arctangent square root of 3 minus arctangent of 1. Then I'm going to bring it up here. So what is the arctangent of the square root of 3? Or in the proper domain, what angle has a tangent of the square root of 3? You can use your reference triangles, 30, 60. So this is something you should know. So this is going to be 2 times, and this angle, the angle that has a tangent of square root of 3 is pi over 3, or 60 degrees. And that's minus, okay, 2 again, arctangent of 1. The angle, what angle has a tangent of 1? You can think of your 45 right triangle, and that of course is going to be 45 degrees, or in radians, pi over 4. So then this is equal to 2 pi over 3, and this becomes minus pi over 2. That's minus pi over 2. You can multiply here by 2 to get 4 pi over 6, and this one by 3 over here to get 3 pi over 6. And this comes out to pi over 6. That's in radians. And that's the solution to that one. Again, you're going to write radians here. 30 degrees in degrees. That's your final answer. Thanks for watching. We'll see you next time.